Many alpha particles will not undergo collision with the gold atoms. As a result, particles pass straight through the gold foil. The nucleus is surrounded by a number of electrons, and the electrons revolve around the nucleus in a what orbit? In a circular orbit, due to the electrostatic force of attraction between the nucleus as well as the electrons. Electrons and nucleus, it's attracted with certain force of attraction, and that force of attraction we call it as a centripetal force. Hello everyone, I'm Brinda, welcoming you all to Chapter 12, and chapter name is Atoms. In today's class, let us just deal with few more concepts about atoms, nuclei, protons, neutrons, electrons and all those stuff. So now we have, according to this chapter, atom is the smallest unit of a matter. That is the main thing what we actually know, universally accepted component. Atom is the smallest unit of a matter. An atom is made up of tiny indivisible particles. So more than atoms, you can't divide the atoms into too many other or the fine particles, okay? So Dalton is the one who postulated that the matter is made up of atoms which are indivisible. Atom is derived from atomos, which means to say it can't be divided, undivided component, okay? So now J.J. Thomson is the one who proposed the first atomic model in terms of plum pudding. So you can see here, positively charged atoms are uniformly distributed throughout, and these negatively charged electrons are the one which is embedded in the form of a plum. That is why we call it as a plum pudding model. The charge of the atoms is uniformly distributed throughout, and electrons are embedded in a pudding type format. That was proposed by this J.J. Thomson. And next we have Rutherford. What exactly Rutherford has told with respect to this atomic model. Rutherford's nuclear atomic model tells that the electrons revolves around the nucleus and the atom is at the center, similarly as that of the planet is revolving around the sun concept, okay? So after which Bohr atomic model came into existence. Because of the failure of Rutherford's atomic model, certain terms and conditions, Bohr's atomic model came, and it told that the study on spectrum of hydrogen atom was given by it, but it failed to explain the spectral lines for complex atom, but only the spectrum of the hydrogen atom was explained. And then you have Sommerfeld's relativistic atomic model, which gave a modification to Bohr's atomic model, wherein it could explain about the complex atoms as well. And next, finally, last we have a vector atomic model. So likewise, there was an existence of Rutherford's model to Bohr's atomic model. From there, Sommerfeld's relativistic. From there, it came a vector atomic model. That is how the model or the atomic model took its new forms. Next is you have alpha ray scattering experiment with respect to Rutherford atomic model, wherein you will study something more about like how exactly the experiment was conducted, what were the procedures taken or the considered, and then finally what was the observation made by Rutherford is what actually the concept tells. So here H. Krieger as well as E. Marsden both performed alpha ray scattering experiment by the suggestion of this Rutherford, okay? So they were the students or the followers, what you can tell. Actually, H. Krieger as well as E. Marsden were working under Rutherford. So Rutherford, whatever instructions he has given, based on that, they had considered this alpha ray scattering experiment. The setup is like you have a detecting screen over here, and alpha particle emitter is this. This is a particle. So it is a lead cavity which covers this source, as well as through a gold foil, and through a thin slit, there is a ray or the radiation which passes through the gold foil and gets scattered, okay? So these scattered were observed. That is the procedure. According to the procedure and the consideration, if you take, consider a source S, which is taken under a lead cavity. The alpha particles are emitted by the source, as you know, and there was a thin slit that is collimated. Beam is collimated with the help of a lead slit, and a thin gold foil is placed at certain distance from the Z, and lead as well as zinc sulfide screen is placed to detect alpha particles. So what is the procedure which takes place? The alpha particles are emitted from the source, which is collimated to a narrow beam with the help of a lead slit, made to pass through gold foil, and through gold foil it gets scattered. And few of the observations are made, and the scattered particles will be observed by ZN screen. Okay, therefore alpha particle produces scintillations on the screen, which was actually observed in your experiment. And next, there are certain set of concepts happening after this. counted at different angles from the direction of the incident beam. So how many particles are scattered, it is counted. The angle of deviation theta of the alpha particles from the initial direction is called as the scattering angle. That one you'll have to know. And the graph is obtained by plotting the further with respect to number of alpha particles scattered as a function of scattering angle theta. This is how exactly the graph is plotted. So for which certain observations were made, and those observations are nothing but many alpha particles will not undergo collision with the gold atoms. As a result, particle pass straight through the gold foil. Whenever it doesn't collide with the atoms of the gold foil, it just passes straight through, and only 0.14% of the incident particles are scattered, which will be more than 1 degree. About 1 particle in 1000 incident particle can be scattered more than 90 degree. So these three are the most important observation which was made by Rutherford's atomic model. Okay. So now that is also called as alpha ray scattering experiment. So what were the features? After looking into the observation of the experimental pattern, there were certain features whichever Rutherford has gave with respect to the nuclear atomic model, and which turned out to be the atom has a small positively charged nucleus. Okay. So atom, this is an atom. Atom has a small positively charged nucleus, and this is nucleus. The red one is known as nucleus, whereas the whole thing is known as atom. So all positively charges of the atoms are, most of the masses of the atom are concentrated in the nucleus, because the positively charges are the one, that is the nucleus is the one which holds good for the mass of an atom. The size of the nucleus is small when compared to the size of the atom. You know, size of the atom is this, whereas size of the nucleus is only this. So nucleus is surrounded by a number of free electrons. That these green particles or the green spheres are called as the electrons here. So nucleus is surrounded by a number of electrons, and the electrons revolve around the nucleus in a what orbit? In a circular orbit, due to the electrostatic force of attraction between the nucleus as well as the electrons. So there is a electrostatic force of attraction. Electrostatic force of attraction between the nucleus and the electrons. That is what holds this atom model. So these were the features of the atomic model of Rutherford, by which he gave an explanation that electrons revolves around the nucleus in a circular orbits, and as the time passes, the electrons revolves and loses its energy at every interval of time, and finally loses its stability and fall into the nucleus is what it's been considered. But that was considered as false by the Bohr's atomic conditions. So let us come to the explanation of Bohr's atomic conditions further onwards. So for which we know Bohr's atomic model gave certain hydrogen spectral series. So let us just check about the spectral series which was given by the Bohr's atomic conditions, which was introduced on contrary to just give a contrary statement with respect to the Rutherford atomic model condition, for which we have series, spectral series. So what is meant by a spectral series in Bohr's atomic model? He has given a spectral series of hydrogen atoms. So we need to know what is a spectral series. It's a set of lines which are spaced between each other as shown in the figure. So you can see the spectral lines over here. Similarly, these are the just general form what you have to know. The spectral series you can see here. That is a Lyman, Balmer, Paschen, Brackett, Pfund series. So these are the spectral series. So how exactly, suppose if you just look into this, you may not get to know what are the spectral series as such, but according to your syllabus, you have a spectral series, Lyman series, Balmer series, Paschen, Brackett as well as Pfund. You can check it out over here. That is in this form. That is, you have energy level, n orbital level, second, third, fourth, fifth, sixth, seventh, first, second, third, first till seventh orbital levels are here, for which you call a Lyman series are the series which falls from the higher orbital or the higher energy level to the first level. Such kind of a series are called as Lyman series. The series which falls from higher energy levels to a second orbital level is called as your Balmer series. Similarly, from higher energy level to the third level is called as a Paschen, and further onwards it's a Brackett and Pfund series. This is how exactly your series will turn up. Okay, so that is all about your types of spectrum what you have to know. And next is Bohr model of hydrogen atom. As I told you, it was told that the Rutherford considered that the electromagnetic waves loses energy. As a result, there is a decrease in spiral orbit and it falls into the nucleus is what it was considered. So this model failed to account for the stability, because of which there was an introduction of a Bohr's model of hydrogen atom. The Niels Bohr made a modification in atom, that is by giving three postulates of it. That is, first postulate, your second postulate as well as third postulate with respect to the atomic model, wherein your first postulate talks about the stability. That means the electrons revolves around the nucleus in a normal path. There is no emission of a radiant energy in case of your first postulate, wherein in case of your second postulate, the angular momentum of the electron will revolve around the nucleus in such a way that it is integral multiples of h by 2 pi. So this is your second postulate, and your third postulate turns out to be whenever there is an excitation as well as the de-excitation, the photon of certain energy is liberated from it. So that photon of certain energy is equal to the final energy, the difference of the energy levels, final energy minus initial energy. So that is all about your third postulate. So there exists your first, second and third postulate, which was brought up just to tell that the Rutherford's consideration was false consideration. And next we are going on to total energy of an electron in a stationary orbit. It's an important set of derivation with respect to your MCQs or with respect to your 5 markers. So it is, first of all, we will have to consider the nucleus with its charge, and the electrons revolve around the nucleus with minus charge with certain velocity v. Okay. Suppose if you consider the potential energy of a electron which is revolving, then we can just give a equation as 1 by 4 pi epsilon naught ZE and minus E divided by R. So U is equal to 1 by 4 pi epsilon naught, it is minus ZE square divided by R. This holds good as the potential energy. We have a kinetic energy given by half mv square. So this is our kinetic energy. We have to check out the total energy. Whenever total energy comes, it is potential energy plus the kinetic energy. Before that, we have the electrons and nucleus. It's attracted with certain force of attraction, and that force of attraction we call it as a centripetal force. Centripetal force Fc is equal to mv square divided by R, and we have an electrostatic force of attraction is equal to 4 pi epsilon naught ZE square divided by R square. So on equating the centripetal force as well as electrostatic force of attraction, we end up in mv square divided by R is equal to 1 by 4 pi epsilon naught ZE square divided by R square. R square and R cancels. So we have mv square is equal to 1 by 4 pi epsilon naught ZE square divided by R. So therefore your kinetic energy becomes half 1 by 4 pi epsilon naught. Let me just write this as Z square and let me introduce R over here. So this is our kinetic energy. So therefore total energy is equal to kinetic energy plus potential energy. Kinetic energy is ZE square divided by 2R 1 by 4 pi epsilon naught plus 1 by 4 pi epsilon naught, and we have potential energy as ZE square divided by R, where this turns out to be negative. So now on taking common out and adding all this, multiplying the signs and all, you have 1 by 4 pi epsilon naught into ZE, and you have R. Within brackets we have 1 by 2 minus 1. So finally half minus 1 is, you have half. So it is 1 by 4 pi epsilon naught ZE square by R and minus half turns out to be total energy is equal to minus 1 by 8 pi epsilon naught ZE square divided by R. So when you just substitute the radius of the nth orbit equation to R, we get the final expression for the total energy. So we have the radius equation as R is equal to n square h square epsilon naught divided by pi m z e square. So this is the equation. Suppose if we consider nth orbit, we have Rn is equal to n square h square component. So substituting the same to the total energy, we will have total energy is equal to 1 by 8 pi epsilon naught Z e square by R. So 1 by 8 pi epsilon naught Z e square. R is n square h square epsilon naught pi m Z e square. On equating, we have pi gets cancelled with pi. So we have total energy is equal to Z e to the power of 4 into m divided by 8 epsilon naught n square h square epsilon naught square. So now z into z, it is z square. So you can rewrite this as 1 by n square, negative of because it is negative, total energy in terms of negative of 1 by n square z square e to the power of 4 m divided by 8 epsilon naught square and h square. So this is the final expression of the total energy. So next we have ionization energy as well as excitation energy. Ionization energy means minimum energy required to remove the electron from a ground state of an atom to infinite state is said to be the ionization energy. Similar way, excitation energy means it's the minimum energy required for an electron to just get excited to a higher energy level. As you can see here, these are the energy level. From one energy to another energy level, if it has to get excited, we have to induce, or it is also called as the energy which is sufficient for an energy to excite is called as the excitation energy. That's all about ionization and excitation energy. Next we have limitations of Bohr's model. So Bohr's model also did not hold good for all set of things, but it had certain set of limitations, that is it couldn't explain the spectrum due to a complex atoms. Next is no information was seen about the spectral intensity of the complex atoms, and it couldn't explain the filling up of electrons to the subshells as well as the shells, and Zeeman as well as Stark effect was not explained by this concept called as Bohr's atomic condition. So with respect to this, according to the second postulate, we have the angular momentum of electron revolving around the nucleus will be h by 2 pi. So for this, de Broglie gave an explanation with respect to the second postulate. So de Broglie explanation of the second postulate or the Bohr's postulate turns out to be there is a nucleus with charge positive, and around the nucleus there is a movement of an electron. Consider this electron is the nth electron and the radius of it is Rn. There is an electron which revolves around the nucleus with certain radius Rn with the velocity Vn, because it's an nth orbital electron, so the radius is Rn and velocity is also nth velocity, so it is Vn. So the circumference of the circle is said to be 2 pi r, which can be written as 2 pi Rn. So with respect to this, it forms a wavelength. So n lambda is equal to 2 pi Rn. So we have lambda is equal to 2 pi Rn divided by n. So this is a set of equation what we have. Now we also know that lambda is equal to h divided by p, where h divided by p with respect to the momentum we are checking the wavelength, mn vn. This is the mass of the nth electron as well as velocity of the nth electron. So when we have this, the lambda turns out to be 2 pi Rn divided by n is equal to h divided by mn as well as Vn. Taking n towards the other side, you have 2 pi Rn is equal to n into h. So I can just divide it by mn as well as Vn. We can shift this nth terms and all and get the constant towards the other side. So we have mn Vn as well as Rn is equal to n into h divided by 2 pi. So n h divided by 2 pi is nothing but your angular momentum, mn Vn into Rn. So this is the equation. As a result, if mn Vn Rn holds good for orbital velocity, then L is equal to nh divided by 2 pi. So this is the equation of the second postulate of Bohr. By this, we can say that de Broglie explained the Bohr's postulate, that this Bohr's second postulate, that the electrons revolve in the nucleus in such a way that it possesses angular momentum which is equal to integral multiples of h by 2 pi. In today's class, we have dealt with the chapter 12, atom concept. Let us all meet in our next upcoming session with a new chapter. Until then, have a good day. Thank you.